Good day, people. My name is Natabu, and today we are doing hyperbolic function. So, I assume that some of y'all, like myself, when you first heard about this, you were thinking of the hyperbola we used to, hyperbola function we used to, like something like this. Uh, mm, even though its shape is not far off, right? But it's not the same thing, at least in this case. Okay. Please excuse my technology a bit. Please excuse my technology a bit. It's kinda doesn't wanna erase. What? Oh, it erased. Okay. So it's not this, right? But rather it's something like this. So we will be working with exponential functions. So the basic exponential functions you need to know in this case is this one and the reflection, which is this one. Ah, right. So it's something like this. Um, it doesn't touch this point though. Erased everything. Okay, let me draw it like this. Something like this. Let's see. So this is our 1 point. So this being our e to the exponent of x function, and then the reflection of that about the y-axis would be this one, the screen one, like this. Remember, this function does not have a lot of discontinuities like whatever it is that I was throwing at first. It's just the technology, yeah. So yeah, so these are the basic functions we need to have understood before we imagine y is on the horizontal axis. Wow. Even try we start getting into hyperbolic functions. So let's get into it. Let's do some work. This is not really work. So for starters, we need to know that there are the following hyperbolic functions. There's this hyperbolic cosine, right? There's hyperbolic sine, and then there's hyperbolic tan. There's a lot more secant, cosecant, yeah. But in terms of sketching the graphs, these ones are a bit easier than the other ones, I would say. So this one you have ex plus e exponent of negative x over 2. Then you have ex minus e exponent of negative x over 2. And this one, sine over cos, so we have ex minus e negative x all over ex plus e negative x. So it's like that, right? Sure. So what we are going to be doing, I'm gonna just sketch a few graphs just to show you the shapes of these. Let me erase. You know, it's not a must to know this, but for interest sakes, I think I'd like to know these. Um, Straight line. Okay. So it's this one is the hyperbolic cosine. It's like a parabolic shape, something like this. Please note, these are not drawn to scale. It's just a sketch. So it's something like this. And so this is the hyperbolic cosine. And then the hyperbolic sine is a bit freakier. It doesn't know how to behave. Ever met someone that doesn't know how to behave? Even in public. It's a bit funny. Always have to tell them, hey man, don't do that. Don't act like that. Don't act like that. So I'm gonna plot the e to the exponent of x over 2 and e to the exponent of uh, and e to and minus e to the exponent of negative x over 2 just as guiders, right? So let's say this passes through 0 and this point is like okay, this is 1. Let's see, this is negative 1, and that means our e to the exponent of x over 2 will be passing here at 1 over 2, something like this. And then this is e x over 2, right? And then the other one will be here. So this is e x negative e negative x over 2. Just like they are reflections of each other, right? Almost identical. Almost twins. Sometimes you don't get completely identical twins. You just get okay. Okay. So that means this one is something like this. And this. Alright, so this is our hyperbolic sine x. It's hyperbolic cosine x. And this could be helpful to someone actually, because I used to think of questions using functions, even though these functions are a bit more my energy consuming. So then there's this one. Our favorite, hyperbolic tan. So hyperbolic tan is quite predictable. I'm joking, you could plot it by putting in points. I just used Desmos. I don't know if you know about Desmos. It's a graphing calculator. But you could plot it by inserting numbers and finding out the value, plotting, and then you got the function. It's like that. So 1, -1 goes something like this. Remember, 1 is at the 2 partner, so 1 is here. I don't know what was I doing here. What were you doing? So 1 is there. So it goes something like that. Right. So yeah, pretty interesting, pretty nice, looks beautiful, looks glorious, beauty of mass. Okay. Let's erase these. They said erasing them, but it has to go. Taking out a lot of space, taking up a lot of space. So now, since we know how our hyperbolic sine, x cosine, x tan, x looks, right? You could also plot the others like hyperbolic secant, x cosecant, uh, okay, cosecant, x and cot x. You could also have a look at them also, right? But now we're going to look at the derivatives of each and every one, right? And how does each and every single one form? So now for hyperbolic sine x, the equation is given by x minus e exponent negative x all over 2, right? And hyperbolic cos is given by x plus e exponent negative x over 2. Hyperbolic tan is given by e to exponent of x minus e to exponent negative x over e to exponent of x plus e to exponent of negative x, right? Now secant, you know from trigonometric ratios that secant was always 1 over cos, right? So in this case, we are just inverting, if you understand what I'm saying. Okay, let me do it step by step. It's 1 all over hyperbolic cosine x, right? So this will give us what? 1 divided by hyperbolic cosine x, which is what? E x plus e minus x divided by 2, right? Which will give us what? It will give us 1 times 2 all over ex plus e negative x, which will give us 2 ex plus e negative x. So this, okay, let me write it properly. 2 ex plus e negative x. This is a negative x. Don't let that confuse you. So this is our hyperbolic secant x. They call maths the language of science. Okay. So now hyperbolic cosecant x, you know that cosecant is 1 over sine, right? So hyperbolic cosecant x is 1 over hyperbolic sine x. So again, we will be inverting, same steps, which is ex minus e negative x. And then cot will be inverting tan, which is going to be ex plus e negative x all over ex minus e negative x. And so, yeah, these are these, and they look good. Okay. So now let's work on differentiating hyperbolic sine x. I think that's easy enough. So we have this is equals to this. Right? So if we were to differentiate this with respect to x, um, we would get that this, before I give you like the final derivative of this, come on, this hyperbolic sine x is equals to, so now what do you think we should do on top? Should we use what's this, the quotient rule? Is it going to be too much work? Should we just use um should we just separate the terms and differentiate them bit by bit? So these are the questions you are going to have to ask when you differentiating. Which one is quicker? Because as mathematicians, we are very lazy people. Oh, I am not lazy, but we are lazy people. And being lazy people, look for the shortest way, or the shortest way to solve a problem, the shortest way to get somewhere, basically. So I think if we were to separate them, it would be shorter. But I'm gonna use a lot of steps because some of us might be starting this whole journey, even though this is a recap series. So yeah, hyperbolic sine x square bracket is equals to. So we're gonna keep product rule. It's still the same, but just to make it shorter, we're gonna keep the constant in front, right? And the derivative of e to the exponent of x is e to the exponent of x then e, which is equals to e to the exponent of x. Right, so it's gonna be e to the exponent of x times 1 times 1. Because then e is 1 and the derivative of the exponent is 1. So yeah. And then minus, we're gonna still keep this, and then the derivative of e to the exponent of negative x. We keep it the same first, e to the exponent of negative x, times it by ln e, which is what? 1, and then multiply it by the derivative of the exponent, which is what? Negative 1. Because if you have d over dx minus x, what will you get? You'll get 1, negative 1. Right? So that's that. So this is that. So what you will get is thus 2ex, right, plus 1 over 2e minus x, which is ex plus e minus x all over 2. And what we saw from the definition of hyperbolic cosine, so that this is equal to hyperbolic cosine. So the derivative of hyperbolic sine x is equals to hyperbolic cosine x. Right? And the same is true for the derivative of hyperbolic cosine x uh, is equals to hyperbolic sine x. Right? But this time, as you know, we used to when we're deriving trigonometric functions, when we derive cosine, we get negative sine. But in this case, for hyperbolic functions, When you derive hyperbolic cosine, you get a positive sign. So that is emphasis, key emphasis. Right? It's very important. Very. I cannot stress how important this is. So it's very important. I'm going to keep this here, and I'm going to write all the derivatives down. Right, so this is how I cram the derivatives. Cramming is the wrong word to use, but you know how students like cramming. So then the derivative of hyperbolic cosine x is equals to hyperbolic sine x. Right? And then the derivative of hyperbolic tan x, this one, is equals to secant squared x, hyperbolic secant squared x. Remember, when you are representing or when you're showing that it's hyperbolic secant x squared, you don't put the squared after you've written before the h. Let me say, you don't put the squared before the h. You put the squared after the h. If that makes sense. Yes. I think it makes sense. I think it should make sense. Yes. So, and then this is the row of positives. I call them the positives. The row of positives. Then when you start deriving the others, the others are not so positive. Yeah. These negative people that come into your life sometimes. So the others is negative hyperbolic secant x. Give me tan x, hyperbolic tan x. Right. And then this one is going to be negative hyperbolic cosecant x, hyperbolic cot x. Right. And this one is going to be negative hyperbolic cosecant x. Cosecant squared x. Alright, so these are the derivatives. As they are, non-changed, non-corrected. So now, let's work on getting a few identities. So, one important point you need to pick up with hyperbolic functions is that they are not trigonometric functions. So, what do I mean by that? Well, the following, this is not equals to 1, but rather this is equals to 1. Oh, how's that possible? I could prove it like right now. It's quite simple, but I'm complaining on time, but I think I should do it. Okay, I'm doing it. I'm proving it. So, prove it, left hand side is equals to e to exponent of x plus e to exponent of minus x over 2, this is all squared, minus e to exponent of x minus e to exponent of negative x over 2. Again, it's all squared. Right? So, you get e. Remember, it's going to be e to the exponent of x squared, so it's going to be 2 times x, so it's going to be e to the exponent of 2x, right? Should I do it step by step? Nah. Let me show off. Shame off. So then you multiply this one and this one, this and this. So after you've multiplied them, you times them by 2, so you get 2 e to the exponent of x times e to the exponent of negative x, right? And then you square the other one, so it's plus e to the exponent of negative 2x. This is all over 4, right? Minus, I'm going to put a bracket. You do the same process, right? Minus 2 e to the x times e to the exponent of negative x, then plus e to the exponent of negative 2x. This is all over 4. So we get e to the exponent of 2x, right, minus e to the exponent of 2x. Then we get plus e to the exponent of 2x. This is like 2 over 2, but I want to show you something. It's 2, what I meant to say, but I want to show you something. That's 2x times e to the exponent of negative, then plus e to the exponent of negative 2x minus e to the exponent of negative 2x all over 4. So what would happen is these, I hope you see the pair in front and the pair at the back are going to cancel out, right? Because it's 1 minus 1. It's going to be 0. Eliminate each other from the race. Yes. So it's going to be 4, right? E, x, right? Please look at this. X minus x. Because you know that rule that said, you multiply exponents with the same base. When you multiply powers with the same base, you add the exponents. So this is what we did. We added the exponents. So it's going to be 4. E to the exponent of 0 is 1. So 4 times 1 all over 4. So our answer is going to be 1. So that's that. Proved and abused. So yeah. Now let's get into questions. I know this is a bit longer than expected. A few questions for the road. It's not a bad thing. It's a good thing. Question number 1 says, u of x is equals to x sine hx minus cos hx. That's question number 1, right? And question number 2 says f of t is equals to arctan sine hyperbolic sine of t. Yeah. And question number 3, just 3 questions, and then we'll be doing more or less. Oh, I'm a funny person, man. Over. Don't do that. So the first one, right? First one will be g prime of x is equals to. So now in deriving this one, we use the product rule, right? So the first part, use the product rule. So we're going to get sine hyperbolic sine x, because derivative of x is 1, right? And then we keep the second one the same, which is sine hyperbolic sine x. And then we add, keep the first one the same, and derive hyperbolic sine x, which is what? Hyperbolic cosine x minus, are we deriving hyperbolic cosine x, which is hyperbolic sine x. So sine x, hyperbolic sine x minus hyperbolic sine x will give me 0. So therefore g prime of x is equals to x hyperbolic x. You could pause the video and do it on your own, especially the following questions that are to come. They are really challenging. They need you to remember one of the things we did in our recap series. One of the crazy functions we did. So you should know that arc, the derivative of arctan x, let's just say arctan x is equals to 1 all over 1 plus x squared, right? So that means in this case, this derivative, what is it equals to? 1 all over 1 plus hyperbolic sine of t squared times the derivative of the inside. So now we're also using chain rule. Touch her outside before you touch her inside. Forgive me for that. I think it'll help with holding the concept. So what we have here is we need to derive hyperbolic sine x, which is hyperbolic cosine x, right? So we will have hyperbolic cosine x, cosine of t, sorry for that, and 1 plus hyperbolic sine squared of t. Now, you also need to remember that since hyperbolic cosine squared of t of x, or t, minus hyperbolic sine squared of t, let's say, is equals to 1, that means hyperbolic cosine squared of t is equals to 1 plus hyperbolic sine squared of t, right? So that says that this part in the denominator is equals to hyperbolic cosine squared of t. So that means that we have this all over, which means we have this right? So now we know what this is, right? We should know that this is. So how do you memorize these? Well, the letters are always opposite. Imagine you only have C and S letters, right? In this case, for cos and sine, you have C and S letters. If it's one over if it's one over cos or one over hyperbolic cos, then you know we have the S. We need to use the S, which is what, the secant or hyperbolic secant. So it's that case. So this is the solution to this problem. Looks cool, looks amazing, looks fantastic. Now, for this one, dy over dx, we are going to have to use the quotient rule for this one. Let me see if I could. Okay, yeah, it's a quotient rule. Look again. It's a quotient rule. Oh, quotient rule is so much work. So with the quotient rule, what we do is we derive the top first, which is going to give us 1. So then we multiply by the bottom, subtract, keep the top the same, and then derive the bottom, which is going to be negative hyperbolic cosecant squared x, all over, you square cot hyperbolic cot x, right? So this is the first step. You could even end here if your teachers would let you. This device is sometimes something else. Okay. Right, and then we have plus. We have plus x cosecant squared x plus cosecant squared, hyperbolic cosecant squared. Then we have hyperbolic cot x squared, cot squared x in fraction form. I don't want you to do that anymore. Yeah, so we have this. So this is your final answer. Looks good. Looks beautiful. Thank you guys for watching. It was nice doing hyperbolic functions with you. Make sure you continue watching because by tomorrow we'll be doing question papers. Interesting. Hopefully by tomorrow. Yeah. Goodbye. Enjoy your day. And we forgot to pray. I forgot to pray. I pray that the Lord blesses all of you. In Jesus' mighty name. Amen.